Hello. Hello, 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 hello. Makes it worse. Yeah, hello. I think, hold on. Fixing my mic. I think that should be good, hopefully. Okay. Okay, welcome back. We are day 6 of streaming. Where we left off yesterday, we were 3D modeling the shooting mechanism. So let's just continue with that, see what comes up. So, what we're doing today, let's pull up the assembly. So let's see how that looks. Yeah, so there's the assembly. So we left off with how to mount the DC motors. So I'm assuming what we can do is just put it on a wall. I don't know how else you would mount it. One thing I do want is like variable width for the or variable location for the motors, just in case we don't have the right dimension for the ping pong ball. So what I mean is that I want a wall to basically, or a rail or a guide to choose the location of the ping pong ball. So how would I do that? That's tough. I think the best way to do it is to line up a guide. Line up a guide. To determine the location of the ball. Not the ball, the motor. Sorry, I'm getting distracted. So essentially what I want is like a rail or a guide so I can move the motor up and down, just in case it's not the right distance. And I think you'll see what I mean. So if I want this on a wall, so we mount this vertically on a wall, and then we give like 2 pins, I'm thinking, and then have the pins slide in and out. And then you could just tighten it down by using a nut and a screw. I think that's the best way to do it. So let's see. So, like, what I'm thinking is something like this. Maybe I'll draw it out first. I gotta bring my tablet. So let's draw it out first. Like this. Sure. So I'm thinking like a wall, and then like a pin, and then like another pin, like this. Something like this. Hey, what's up, Dane? You are pretty early. We just started. Right now I'm just trying to think of a way to mount the motors. So I'm thinking of like a wall. Something that looks like this. Like that. And then we put the motor on this side. So something like that. And then we put this on a slot so that we can move it back and forth. That's what I'm thinking. Huh. Your dog sat on your foot? Classic. What kind of dog do you have? If you have one. Well, I mean, obviously you have one. What kind of dog do you have? So I'm thinking like a box. It doesn't have to be a box, I guess. kind of confused on how to mount this correctly. So how do oh, I should not bring that over. How do slots and motors, I don't know if that's even the right way to even describe it. You have a staff. I'm not sure what kind of dog that is, to be honest. A staff dog. Oh, okay. It's like a bulldog, but not really. Bull terrier. That's pretty cool. I don't have a dog. I don't have any pets, unfortunately. Electric motor design basic tutorial. I don't need to know how to design a motor. I need to know how to place a motor. Like, how does a tensioner work in your car? Tensioner pulley. Let's try that. How do these things work? That's not exactly what I want. Because I'm thinking to mount the motor, maybe put like a nut right here. Oh, that is your profile picture. Oh, I see. Oh, so that is your dog. It's a pretty cool dog. Huh. What's his name? So motor. I don't know how to make this how I want it. I want it to be a slot. Best ways to mount motors, I guess. Rex. Rex is a good dog name, I'm not gonna lie. Pretty classy, can't go wrong with it. How do you... That's not what I want, though. That's what we're gonna get. Damn, I don't know how to do this. So, the issue I'm having is that I don't want to place these DC motors in the wrong spot. Like, let's say I put them in a position that's too close to the ball or too far away from the ball. I want to have the ability to adjust the motor's like locations just in case there's an issue like that. So that's why I wanted to put on a slot instead. So I'm just trying to figure out how you would lock it in terms of a slot. I'm thinking that's what I was drawing over here. Like you have, maybe you just put something like this. Like, let me zoom in. I don't know, something like this. And then we have like a screw go all the way through. And then from there we could just put the motor on here like this, and then that way we have a you know, put like a nut here, or a screw, doesn't matter, and then we'll be able to fix a location by tightening the screw and the nut. So that's what I'm thinking. So we could do something like that, I believe. I think that'll be fine. So let me try to make that. So this is what we had yesterday where we left off. Pretty crude, to be honest, but we'll redesign and fix it and make everything look nice. So what I want to do is make this rectangle like that, And then what we can do is extrude it. Something maybe at least like 4 inches maybe. Oh, 4 inches is way too much. 2 inches. That's still too much. 1.25 inches. That's better. I think that's fine. At least for a good starting place. And then what we can do is maybe can we do this? Can we make this hollow? Yeah, we can do this, I think, just for now. We don't have to make this perfect. Oh, I realized I didn't make the sketch correctly. For some reason, that didn't work. Okay, well, let's restart that. That went wrong. Delete this sketch. So let's go here, and we'll sketch it again. So up to the bottom of that, and then we'll extrude 1.25 inches. Yes, okay. And then we'll do this. Oh, it's still doing it. Or maybe not. Or is it? Yeah, it's still doing it. Why is that? I really don't know why that is. My old one got wrecked. Why? What'd you do on that old Reddit account? So I'm gonna shell it. So we'll do this. We'll shell this, and then show preview. Sure. We'll just do that for now. So now this is shelled, meaning it's hollow, and then we'll put a slot, something like this. That and like that, and then we'll make these equal, and then we'll make this equal like that, and then these are horizontal or collinear, and then we'll equally space them. I don't know how big the, I guess this is our choice, but we can make that maybe 0.75. That should be fine. And then we'll just center it relative to the box we made. So we'll just do this. I want that point. There it is. Shift. Make this vertical. So now it's symmetric. And then we could probably make this like 1/4 inch. Oh, it's already 1/4. Well, actually, 1/4 inch is pretty big. Let's do like 1/8. So 0.125, something like that. And then I guess we have to define the length of this. We'll make it 1 inch, I guess. And what else is undefined? The location, obviously. So we'll make this symmetric with the whole thing. So hopefully, if I did my math right, I didn't do any math, but if I did everything correctly, we should be able to have, we should be able to move the motor onto this mount. Oh, I realized we need a slot for the motor. That is also true. Let me just do this. Edit this. We'll put another slot, I guess, right in the middle. Something like that. Make this coincident. Too much stuff, but overall, I had a lot of people who know who I am in real life. Oh, I see what you mean. I don't ever use like Reddit as a well, I don't know. It's not like a website that I use to like talk to my friends. It's just like a website to browse, for my opinion. You know what I mean? Not that you could use it to make friends and stuff, but it's just like, I think of it as more of a browsing website than anything. Maybe that's just my opinion. Yeah. I mean, I usually go on it once a day, minimum. It's saying a lot. So, 1/4 inch. Coincident. Okay, we'll have that. So in theory, if we exit the sketch, it will have 3 slots. So now we have some play to put the motor in. So let's see how the assembly looks. So let's put this. It's too small. Great. But in theory, if we did this, so oh, is it because the whole Corona thing, is that the only way you can communicate? Damn, that sucks, to be honest. The cool thing is that we could create what do you call it? We could create mates that are mechanical, meaning we could create relationships between different parts using mechanical concepts. So, for example, we could go here and use this thing called a slot. So our constraint is gonna be here, I believe. Constraint, center and slot, and then there we go. That's pretty much it. So now we have the ability. Wait, that didn't work. Oh no, that actually broke a lot of things. Let's not do that. Let me try it again. So we need a slot. Center. Free, I guess? I don't know. Let's try this one. Does that make sense? Okay, no, we don't want that then. Huh. How do you do it? Yeah, and you broke. Oh, I see. Now I see. Yeah, that makes sense. You broke your phone, so now you gotta use like websites and stuff. That makes sense. Oh, well, I hope you get a new phone soon because it's kind of useful. Does this work? Why doesn't this work? What's wrong with this? There's something wrong here. Yeah, why isn't it working? Okay. Do that, and then we'll do this. Please select the mate type. Coincident. Add this mate will break. Okay, well, Jesus. This is what you don't want to see. Oh no. This is what I don't want to deal with. There's so many errors. Why? Why? It's such a simple thing. Jesus. So the whole idea is to put the motor in this slot. If I can show you guys something like that, so that I have the ability to move the motor up and down the slot, because I don't want to like define a slot for the motor, because there's a possibility that the motor will be too close to the ball or too far away from the ball. So I don't want to choose a location. I want to get a range of locations that I could put. So that's why I want to put a slot here, so that I could just basically move it where I need it to be. I mean, over time, given the strength of the motor, or the vibration of the motor, it can weaken the nut and screw. Like, it could get loose and it could wobble and stuff like that, potentially. So that might be an issue. But since this is a small DC motor, I'm not really worried about it. It's negligible, I think. But, surprises do happen. So that's what I want. I want to slide the motor up and down. So in theory, it'll control the width of this how do you say it? The distance between the motor and the ping pong ball. What is this? Let's delete that. And then that one's fine. Okay. So this should be free to move and rotate. Okay. We'll do that later. So let's try this again. Hopefully it would work this time. So we need a slot. Put that here. Free, I guess? Sure. So now, yeah. So it can't move outside the slot. But the problem is that it's still not constrained, at least vertically. So we need to constrain that. Ideally, we want this thing to be against this wall. So now, if we do that, we should be able to slide the motor back and forth. I don't know which side the motor is on. Which side is the correct direction in terms of... I guess it doesn't matter because we could switch the polarity, right? So if you put a positive lead here and then the ground here, or power and ground on this, or if we put power on the left side, ground on the right side, and if it spins in the wrong direction, we just swap the wires, right? I would just reverse the polarity of the object, or of the motor. And then if that's the case, if you want these motors to spin in the right directions, we would set one motor and then flip the polarity on the other motor if they're in the same orientation. Unless we flip the motor physically, then we could do that as well. No, flipping the motor doesn't matter. So yeah, we would have to reverse the wires on the motor. So we'll do something like that basically. So this is still not constrained because it could still rotate. So let's just further constrain this. We would probably want the leads to be on this side so we could wire it and like have the wires route outside the box, if that makes sense. So it'll be like something like that. So we'll put the wires like here, and then it will go through the bottom, and then so forth. So what we could do is make this parallel to this wall, like that. We'll constrain it in that direction. So now this motor, if you look normally to it, it should move up and down. So again, if I don't know if all of you there's 4 people here. If you guys don't know why I want the motor to move up and down, essentially the wheel could potentially be not in the right position if I define a specific location for the motor. So I want a range potentially, so I could decrease the distance between the ping pong ball to get a better maybe there's a sweet spot for launching the ping pong ball. So I could fine tune that by the location of the motor. But I realize this box is a little too small, because like what I'm thinking is put like some sort of like guide here. Yeah. Some sort of guide. Yeah, I need this to be way wider. So let's go and edit that. I think you guys are seeing what I'm trying to do, maybe. I don't know. If you guys are confused, let me know. I could explain it a little bit better. But let me edit this. Let's make this like 1.5 inches then. That may be too wide. 1.25 inches. Yeah, that should be fine. Exit sketch. Now that is incorrect because we need to make this bigger. Edit sketch. Oh, that's right. Shoot. Okay, we'll do this then. Hopefully this will work. That's not gonna work, is it? Oh no. We'll just do this arbitrarily then. Can I go normal? Oh no. Yes. Oh no. I did what I didn't want to do. But is it this one? That's this one. Okay, so what I want to do is make this collinear, and then maybe make this go to the edge of this, and then make this parallel to that, and then maybe I don't know how big to make this. 2.5, sure, why not? Or 2.25. Yeah, it seems symmetric. Okay. If we exit, oh, it's still an issue. Jesus. Oh no, this is bad. Okay, let's go all the way back to where we messed up. Jesus. I'm usually not this bad it's just like I'm prototyping as I go. Usually I have it like all drawn out before I start doing stuff. But did I? Yes. Yes. Okay, I think we're okay. We're still fine. Oh, that's not good. That shouldn't happen. We're gonna pretend that doesn't happen. Jesus, why? Why? Okay. I know why. Because the slot is determined based off this shaft. So this concentric I can't even say the word. The two circles being concentric are valid for the slot, but it's not valid in terms of geometry of the motor. So there's an issue. We could probably limit the position of the motor so we don't have that anymore. So yeah. So what I should have done what I should have done. I should be saving files as we go. So just in case if I mess up, I could go back to an old like file save. But it looks like I didn't do that. But now I want to restart this. Oh, I realized that this is not even. This is intersecting with that. Yeah, I did this all wrong. Okay, hope you guys don't hate me, but we're gonna start over. Jesus, here we go. We're gonna go back to here, and we're gonna take all this stuff off. I think this is fine. So yes. Okay, we're back to this. Okay. So what I want to do is do this instead. I think this is a better idea. If we just go here, what's up, Jack? Haven't talked to you in a bit. Here we go. Do that. And then we'll do this as well. So, usually can't type and I'm at work right now. You're at work right now? Damn. You go to work late. Gotta get your money though. Alex's poetic voice, yes, I do have one. So we finished this. I forgot how far or how big we made this already. 2.25 or 2 inches. Let's make this 2 inches. That's fine. And then we'll make, what's the height of the motor? 1.5 inches, 1.75 inches. 2 p.m. to 10 p.m., bro. Yeah, fuck that. 10 p.m. like, I don't know about that, man. I mean, I go to bed at like 9, 10. Or like sometimes I can't sleep, so I'd be up late. So if we mirror this, entities to mirror, we'll mirror this. Yeah, Dane's from Britain, so that's pretty gnarly. It's like fucking like early morning for him. That's more nuts. No offense. And then we'll extrude this in the opposite direction though. I don't know, 2 1/4. We'll do that. I think that's a better. Damn it, we don't want it that high though. We can't do this actually. So what we want to do is get rid of this relationship, as in this geometric relationship. So yeah, this is not coming out well at all. Let's see, horizontal or coincident? Coincident. There we go. Now we're getting somewhere. So we'll just do this horizontal. Oh yeah. And then we just connect some dots. And there we go. Yeah, I should be charging like $100 per hour for this stuff. I mean, I'm practically working 10 hours a day. Engineer at work and engineer at home. But this is way more fun than work, to be honest. Or at least way more interesting. Be fun's a different word. There you go. That's what what I was looking for. It looks like a Canon or a camera without the lens. Or it looks like a flagpole thing. It is the spooky hour. Yes, it is spooky. Was it the hour of the devil's like 3:33 a.m. or something like that? At least that's what I heard. I haven't tested out that theory. Usually I skip the devil and go straight to the... Never mind. I'm gonna leave that personal. Yeah, so back at it again. I don't know how big the motor is though. Yeah, there's still issues. We'll delete all this stuff. Yes to all. Here we go. Okay, so before I start doing all the crazy stuff that you're thinking the fourth kind. Now, well, yeah, I think. Well, the fourth kind, does it have the 3 o'clock thing? I don't know. I don't know about that. I was talking about like YouTube videos when they like wake up or stay up at like 3 a.m. and then they determine, or like a fidget spinner starts spinning because like there's a devil in the house or something. I was talking about more like that. 1.94. Oh, you want to work in NASA? That's pretty cool. Do you know like what part in NASA? Or like something in NASA? Does that work? Let's say 2 inches. 2 inches. So we can make this a little bit smaller. Actually, that'll probably be better. Instead of 2 inches. Oh, it's already 1.25 though. Why is it smaller? Wait, I did something wrong. There's definitely something wrong here. I didn't measure. Oh, wait. No. That's not how that works. So if I measure the top and then measure the bottom. Oh, the perimeter's 2 inches. The height is 1 inch and roughly 1/4 or 1/8 of an inch. So 1.25 inches. We go 1.5 inches. No, we need that close to the top. Then we go 1.5 inches. We'll figure out the rest later. So let's make that 1.5 inches. Hubble telescope in some way. That'd be pretty cool. I really don't know what I was looking into deep space or looking into the past. Is that how that works? I don't know. I forget how that works. Redshifting and all that stuff. Like classic physics class. Don't get me started about space though. I'll go on a I'll go on a stupid tangent. Like completely stupid. So it's an inch tall. We'll make this bottom side hollow. So we'll shell this like that. It will show a preview, 1/10 of an inch. Maybe too much. 0.075. Let's see, 0.075. Ooh, there's an issue here. Well, now I'm starting to think about like how am I gonna 3D print this? Oh no. Now I'm getting like issues with 3D printing. I'm thinking way too far ahead, but if I 3D print this, there's gonna be a lot of support material just because this part is hollow. So I don't want to do that. I don't know how to design something like this because I need the motors to move. I don't know how to do this besides. What if we did this? Now I'm stuck. I don't know what to do. This should be a simple design, but now it's becoming complicated. It's just a box and a cylinder. What we can do, I don't know what we can do, to be honest. So I need this to not be hollow if I want to print it. Well, I'm stuck. Do we... I'm just trying to figure out how to attach it. Unless there's a different way to mount the motor, because I can't really think of one besides having some sort of guide or a slot. Because I want the motor to have some movement if need be. What if we would putting the motors up here be a different? No, we probably don't want to do that. So if we put I can't, because I can't 3D print this as one part. That's like the main issue that I'm getting here. Because like if I were to print it such that the bottom or the bed, if this side was the bottom of the printer, so to speak, so I was printing left to right, this hollow space cannot be printed. Like this wall won't be able to be printed. There'll be so many issues unless I use support material, but that's so much support material, which is so unnecessary. So I don't want to waste the 3D printer filament. If we print this way, we still have the same issue. If we print this way, it's not really possible. So we can't do this. We can't. Like, it's not optimal, at least for printing. There has to be a better way of mounting it. I mean, do we need this wall? I guess structurally, yeah, because the motor would vibrate quite a bit, and I feel like since there's no support for this wall over here, then it'll cause it to like go like this, or like go back and forth, and that could be an issue for launching the ping pong ball. So we don't want that. Huh. Now I'm really stuck. What if we did... Here's a design. I think we could do this instead, actually. I mean, it's kind of a workaround of what the issue... Oh, I realized if I print this way, this slot would be an issue as well. Damn. Working with the cylinders, like, causing a lot of issues. Okay. Let's go back to square one. Jesus, like, this was a lot more complicated than it needs to be, in my opinion. But yeah. So we don't. So this is the barrel. We want it to launch. I'm going to go in a few minutes. Alright, that's fine. I'll see you in a bit. Or if you come back for the next stream, that's cool too. Well, we're back to square one, which is the cylinder. Or should I say cylinder one? Not my best joke, but I'm stuck. I'm already stuck. I don't know what I'm doing anymore. I'm gonna go get some inspiration from the internet. So, tennis ball shooter. Let's see how they set it up. Tennis ball launcher. So something like this. For tennis ball. Tennis ball players. So let's see. Yes. How do they do it? Let me see a bigger picture. Oh, that's interesting. They put it vertically. I didn't even think about that. Oh, they also put it horizontal. I guess you could rotate the thing. I guess it doesn't really matter. But it looks like they feed the ball into the tennis ball shooter. The problem is that I can't print this or 3D print this properly without using a lot of support material. And support materials is like this filament. Maybe I can show you. Support material is like filament that's not used in the final print. It allows you to create more complicated structures because some of the part is like in mid-air, so to speak. Like it's not supported underneath itself. So if you look here, like this one for example, maybe open image in new tab. So it's not a best image, but the black part or the black 3D print is the actual part, and then all the white stuff is support material. So when you're done printing, you could take out the support material and you'll have your part. So you have like hanging supports, or a part of the part is still hanging and you need support under it to print onto it. Like you can't print in mid-air. Like you can't do that. So the problem what I'm having is to create a part that doesn't have any support material, or at least very minimal, because I don't want to waste filament. And plus it's not my filament. so I don't want to really get an issue with that. So that's why I'm trying to think of a different design of how to put the motor or something. Oh, what's this? Oh, this is cool. I use a corkscrew to bring up the ball. Not what I wanted though. What is this? That's not a tennis ball shooter. This is a tennis ball shooter. So it looks like they rotate the nozzle. How's it supporting in this one? I don't know how to change that. And plus I need to print it within like a couple hours, so like the CEO doesn't see it, because he's usually there late and he checks if everything's turned off. So I don't want him to see some shit that's printing overnight that's unrelated to work. So that's also a reason. Oh, I'm using a lot of RAM. Oh well. Yeah, I don't know how to. Huh. Maybe we could steal that design? Maybe? So... yeah, we could do this. This might be weird, but we'll go on the side plane and we'll draw out a sketch. Maybe something like this. I guess this will be collinear, and then we'll make this kind of large. So 3¼ maybe. And then we'll taper out the rest. Something like that. Yeah, like that. And then we'll trim this. And now we should be able to do a cut, so extruded cut through all both. So now we get like a half tube, right? And then we could put, so now we don't have the issue of printing that square, but that's probably too big. We could probably make this a lot smaller, 2.25. Okay, didn't like that. Let's delete that. Is that possible? It's possible, but it's too small. Something like that. I think. And then we'll dimension this. Inch and 125. And then we'll exit sketch. I think that's a little better. We'll probably make the tube a little longer too. Maybe 6 inches, like that. Yeah. So we could do that. That way we can still print and put the motors here. Is there an issue with that? Like if we were to tilt the ping pong ball shooter thing, the cylinder, will that be an issue? Yeah, we're not going to launch at 90 degrees. Like, that is our maximum, and you're not going to hit anything at 90 degrees. Unless you're just, like, messing around, but, yeah. So, we should be able to launch that. Now, we have to mount the motors. which I think what we can do. Uh, I don't know how to mount the motors still. I'm still confused. Like, it has to be a wall of some sort. I guess we'll save this. So we'll do something like that, and then maybe build a wall going downward. Oh, this is gonna look so bad. I don't like how that looks. Because now I'm worried about the support for, like, making sure it's, like, structurally... Oh, no, we can't do that, actually. Oh, no, we can. No, we can't. Damn it, we can't do that either, because then we can't print the wall. So what I'm thinking out loud, right? So if this is how the print's gonna go, like, this is gonna be the bottom of the print, we could print this. But if I put a wall right here, like, if it stops from, like, here to here, we can't print that wall because it's suspended in air. So we can't do that either. God, now this is actually a design problem. I don't know how to do it with the constraint of a 3D printer. Now I'm thinking we should switch the design. I'm now thinking, like, oh, we should just use, like, a fan or something, or like or maybe a spring. Yeah, I can see your comment, Dane. I think you sent that just recently. So, back to the drawing board, I guess. I don't know. Now I should consider that in the choosing of our mechanism. If we could 3D print. See, originally I had it as just like a half tube, but I don't think we want that, because we want to control the location of where the ball goes. We don't want it by accident. That's interesting. Okay, let me just look at more designs then. Oh, we can go with the spring one. I'm starting. Once I saw this, I realized we can use a spring, because it'll be no different of just, like, bringing this thing back and then locking it and then letting. Oh no, we can't do that. No, we can't, because that would give us only one output, meaning, like, there's only one power input or out. Like, it's a max or none, right? It's not analog, or it's not variable. Dang. I'm not sure. Tennis ball. Like, this is what I'm looking for. Something like this, but it just doesn't make sense. We could buy some PVC pipe, but the accuracy or location of the of the motor is probably not going to be accurate, because then I would have to, like, cut into it. See, the interesting thing about these is that they the wheels or the motors curve with the curvature of the tennis ball. So that's why they could just make this weird looking scoop thing. All right, Dane. It sucks that your internet's lagging out, but if you could catch the stream tomorrow, definitely, because it'll be archived. So yeah. All right, man. So what can we do? Yeah. Now I'm just like lost. Like we're not progressing anymore. I'm just like stuck. Oh no. This is what I was afraid of when I started live streaming. Getting stuck and then not knowing what to do and then just mindlessly go on the internet for like 2 hours. Oh no. My worst nightmare. Yeah, I'm not sure. Now I'm just mindlessly clicking. Tennis ball launcher. This thing. How does this thing work? Can we do something like that? Oh. Oh. You will be streaming tomorrow, or is it two a week? Today is Wednesday, I believe, right? So the next stream will be on next Monday. Yeah, so 3 a week, Monday, Tuesday, Wednesday at 6:30 p.m. PDT. I still don't know what the acronym stands for, but Southern California. So yeah, next stream will be next week. So. What we can do though is like create 2 pieces and then just mount them together. We could do that. That way we don't have any issues with printing potentially. We probably still have issues. I feel like there'll be an issue. Yeah. So maybe we could do that. That'll be cool. Now I'm thinking if there's any issues with that. If it's not a weird shape, it should be fine. No, we can't. It's the cylinder that's messing it up because it curves. That's the issue. All right, Dan. I'll see you next week if you're gonna catch the stream. So maybe we can do that or can't do that. I don't know. I really don't know. How does this thing work? That's not even like what I'm looking for. How does this thing work? Oh, well, I guess it's not like how it works, but how it's designed so I could 3D print it. Okay, I'm gonna do some research, some real research. Grab CAD, tennis ball shooter, or something like that. Let's say ping pong ball. What is this thing? How does this thing work? Is this all a part I've made? I'm kind of interested in how this thing works. It's not loading. I'm just curious on what it is. I'm inspired a little bit. Let me move this off screen. Hold on. Gmail.com. Nope, that's not what I want it to do. Sign in. Download. Is it downloading? I'm not sure. Okay. This is not cheating. I'm just researching. File Explorer. Yes. Open. Extract. Yes. Okay, I just want just want to see what it is. Okay, this is fine. So how does this even work? What did this guy even make? I don't see how this thing works. So I'm assuming this is where, like, maybe this is like a... Oh, does it... No, I don't think it does that. I'm assuming, like, this thing retracts and goes back and forth, and then it launches through this thing. But why is it, like, all weird? I don't know what this guy did, to be honest, but he had an idea. I'm not sure how that would work. Let's see. I just need to... Let me type in ping pong ball launcher. This is probably cheating, but it's not really. If I figure out something. How about this one? A footrest? That's funny. I don't know how to do it. I don't know how to design this thing, to be honest. I'm stuck. I'm fully stuck. What we can do, maybe, just maybe, it's not loading anymore. That's great. Yes, update. Let's cancel this thing. Okay, let's think of different ways to mount the ping pong ball, or the motors to this thing. We need it to the side. That's a given. Maybe we'll just have the tube by itself. Like, this is its own part, and then we just 3D print something else. So maybe what we can do is this. Maybe this is a better idea. Oh, we still can't do that. Oh, this is so difficult. Okay, screw it. We'll do this. Can we do that? Okay, what I'm thinking is maybe put like some notches here so we could mount some screws. So what I'm thinking is like something like this. So we'll sketch this like that, and then we'll connect this dot on here, and then we'll make this, I don't know, 0.125, I'm assuming, roughly there, and then 1/4 inch, maybe a little bigger. 3/16 is smaller. 5/16 maybe. That should be enough room, maybe. Yeah, that should be fine. And then we basically mirror this. We don't have a line to mirror it, but maybe you'll see what I am thinking. Make this coincident. Or just make this vertical. Make this vertical. I think I'm onto something. So if we do that, and then, okay. And then make this coincident. Why can't we do that? Oh, I know why. Make this vertical. There we go. Okay, and then we'll mirror this like that, and then we'll extrude like that. Maybe an inch. Yeah, well, maybe an inch is too much. Maybe a 1/2 inch. Yeah, that should be fine. Do something like that. And then we'll just mount some holes, or mount some screws here, like some screw holes, like that. And then we'll make these equal. And we'll make this vertical, and then we'll give the size, I don't know, we'll use like a 440 screw or something. So do I have 440 screws? I probably don't. I have some sort of screw. I forget which ones I have. I forgot. Wait, let me see if I have the... I think I have a purchase order regarding that. So let me see. Screw. Oh, I did buy 440s. So 440s. So we'll just look up clearance for 440s. If you guys don't know how to read screws, basically, I believe how it goes, don't quote me on this, but the 4, I believe, is just like a standard number, I believe. And then the 40 is how many threads per inch. So if that makes sense. So I think 1 revolution is considered a thread. So if you have 40 revolutions, that is 40 threads, if that makes sense. And then I believe the 4. Well, let's look it up. Let me just make sure. What does 440 mean? I'm pretty sure that's what it means, though. But I could be completely wrong. Yeah, 40 threads per inch, and then yeah, I think 4 is just a number. It's nothing significant. Yeah, and they also call them like number 4 screw or number 6 screw. The most typical ones I've seen so far is 440s and 632. Again, 40 being 40 threads per inch, 32 being 32 threads per inch. And then also the threads, the number of threads, determine basically how what do you call it? How strong the connection is, or the screw is. What does it go over myself for kicking me off? God damn it. How big is your dog relative to you? Is it like a big dog? I don't know how big staff dogs get. What? So what we want to do is hole clearance size for 440. Free fit. Here we go. 30.112. So a quarter of an inch. I mean an eighth of an inch. So we'll just do that. That should be good enough. So we'll do a quarter of an inch, or an eighth of an inch, something like that. So that should be way more than enough to clear the screw. We'll just have to put like a nut or something, or a PEM nut on the other side. So we'll make this all nice and symmetric. We'll do that as well. So horizontal, and then we'll do a cut. So now we'll do throughout both. So there we go. Something like that. I think that's fine. Again, what I was talking about yesterday is stress concentration, meaning meaning there is potential failure points in terms of like forces being applied. So whenever you have a transition from, a larger area to a smaller area, you want the transition to be as gradual as possible. The more abrupt it is, the more potential it has to break. So if you look at this section right here, you see how it's just like a right angle? That's pretty bad, because if I were to like basically pull on this or tug on it, it will more than likely rip, and it will break at the seam, so to speak. So To combat that, there's this thing called a fillet, or it's basically like a border radius. So it does something like that. So that basically frees up the stress, so to speak. The larger the radius, the less stress it has. The smaller the radius, the more stress it can have. So we'll probably make this 0.05 so we could have clearance for the screw. But we could change that later when we put the screws in. So something like that. Even on this side, I realized should have it. So let's edit that. So that it's nice and filleted. Like that. So it just decreases our potential of breaking, which is likely since we're going to put the motors over here. Maybe the weight's going to be too much. But since we have this, we have it 3D. It's 3D printable now, right? We could print from here. The holes might be an issue, but we could put support material for that since it's like 1/8 of an inch, which is really small. So it's not going to be that much support material for these holes. So we could print it vertically, and we should be able to mount it onto something. Yeah. So maybe that's how we'll do that. I think that makes sense. Yeah. So and then we'll basically mount this onto like a base, and then we'll be good. Now I want to make this shorter. I don't like how long it is. Let's go back to 4 inches. So that may be better. And then maybe we'll change this to, I don't know, 2.5. That should be fine, maybe. I'm not sure. Something like that. So 0.75. Like that, and then exit. So it'll be something like that. I think that looks pretty good. We could fillet this maybe to make it a little bit nicer, but it's highly unnecessary. Not necessarily that edge. I want this. Yeah, I want that, but make this bigger, like 0.75. Oh, that's too big. 0.2. Yeah. Something like that. Oh, this is not working how I want it to be. How do I... Okay, we'll just make 2 of these, I guess. We'll fillet that side, and then we'll fillet this side. Something like that. Full preview. Yeah, there we go. So now it's like a nice scoop. Something like that. So, there we go. I think that we'll work with that for now. And then we'll put the motor here on this side. If we have enough room, I didn't count for that, I realize. We'll check in a bit. But we'll use this as the main barrel, and then we'll have a bottom base to connect to it. Yeah, I think that'd be fine. So, let's create the base then. Let's see. Create a new file. And then we'll sketch this. Maybe we'll do this instead. I don't know which side this is on, so okay. Yes. We'll close this for now. We don't need that yet. We'll do this. And then we'll do this. And then we'll cut this out. And we'll make the symmetric like this, equal. And then we'll make this equal as well. And then that'll be it for that. And then we essentially just define our sizes. So the outer diameter of our tube is, I forget, what is our outer diameter? Diameter is 2 inches. So we'll make that 2 inches, or roughly, maybe a little bigger. Oops, I didn't mean to do that. What'd I do? There we go. Okay. 2 inches, so maybe slightly bigger than that. So let's go to, why isn't this popping up? Close that. Okay. So we'll make this slightly bigger than 2 inches. Maybe, I don't know, 2 1/10. Oh, we have to do it in, so an inch, 0.05, like that. And then we'll just make it 2 inches, screw it. So it looks nicer. And then we'll make this an 1.5 inches, I guess. And then we'll make, oh, I don't want to make this too thick though. We need this to be like, what, 6 inches? No, it's way too big. 4 inches. Maybe 4 inches will be wide enough. Okay, and then we'll extrude. And we'll make this a... Your dog fell asleep. That's pretty good. Classic. 5? Oh no, it was 4, right? We made it 4. Something like that. Looks like a half pipe. That's what that looks like. Now I gotta think about how we print this. Okay, let me put this in the assembly so I can see how this looks, because I can't really think out loud here. So let's make a new assembly. We'll save this as 05-004. And then this is an assembly. We'll place this there. No, that's not what I wanted to place. Hold on. Delete this. That. Let's place that. Insert components. This. We'll place that there. And we'll make this concentric. With that. And then that's basically how it goes. We just need to make this parallel with the top face. So something like that, and then we'll put, we'll basically screw it on to this base. But I don't want it to look like this, because this is excess material for no reason. Oh no. Maybe what we can do, we could taper it downward, but we need room for the motor as well. And I feel like this is gonna be too wide for what we're trying to do. Oh, this thing's actually pretty small though. Like it's probably like, I don't know, as big as my hand, maybe? This is not that big. So, hmm. What can we do? Because I need this to be hollow. So I could print it. Or not print it, but put the motor inside. But that causes a lot of issues. So, well, at least for 3D printing. So we can't have it hollow. Hopefully you guys can't. Sorry for the background noise if there is any. Um, but I can't. I'm really stuck on this design of how this mechanism is printed. It's mostly the 3D printer that's holding me back. Well, let's insert the ping pong ball just to make everything look nice. So let's do that, and make this with this concentric. So we'll have like the ping pong ball, a launch out, like boom. It's probably not an issue if we have it hollow. Let me just think. We still need to mount the motor somehow. That's like the biggest problem I see. We could mount the motor vertically. Does that even matter though? Like, why would there be a benefit of mounting the motor vertically? Now I'm getting now I'm lost in the design again. So if we put the motor on top, we could launch it going, or we could orient it the. No, we can't. Never mind, because the orientation of the motor is not like. It's not. It's not in the same direction as the pipe or the tube. So that's not gonna work actually. Huh. Yeah, I'm really stuck on this, to be honest. It's not looking so good, to be honest. If you guys have any ideas, I need help me out. But God, this is a lot harder than I thought it would be. It's mostly because I want to 3D print this. If I don't 3D print it, then what can I do? I mean, I would have to get like a part machined. I don't have any access to that, and it's also very expensive for like one part, like a singular part being made. So that's an issue, and plus it adds weight. So we don't want to use metal, or at least try to use the minimal amount of metal. We use sheet metal maybe, but like that's still heavier than plastic. So, and we don't want to be too heavy because it'll stall the torque of the motors, or the stalling torque of the motors will be small because they're going to be servo motors, and those things have maybe a foot-pound of torque, meaning like it'll stall if you had like a ruler or like a 12-inch slide or whatever you want to call it. If you put a pound at the end of it, that's how much weight. If you hold on the other side, that's how much weight the motor can like withstand. So we can't do anything worse than that, or any more weight than that, if that makes sense. But we could be very clever with it and put the whole mechanism as close as to the closest it can be to the rotational motor or the servo motor, like the rotational axis. So that way we could decrease the torque, because now the center of mass is closer to the motor, therefore causing it to be how do you say it? Less of a turning tendency, if that makes sense. So, we could think about that as well. So, but I want to stick with plastic or filament, 3D filament, because I have access to it and it's practically going to be free. It won't be expensive to machine something like this. And if we were going to machine the base, we would have to find some sort of pipe or tubing that we can use for the ping pong ball. But there aren't any standard sizes for pipes relative to the ping pong ball. Because the ping pong ball is slightly over 1.5 inches, and that just messes up everything. Since the next size up for a pipe, like PVC pipe, it would be 2 inches. So we can't find a standard pipe either. I mean, we can use 2 inches, but I think that's too much of a space between the ball and the tube. So that's an issue. Originally, I wanted to go with PVC pipe, but I think it's just too big for the ping pong ball. So what can we do? What are different ways to mount a motor? We could use a slot, which is what we did originally. We could do that, or we could Now I have a question. Do the motors have to be like horizontal, if that makes sense? Like, can they be like this and still have the same effect? You know what I mean? Like, do they have to be collinear? If that's the case, then maybe we could have a clever design, like a V8 engine. You know what I mean? Like, we have like motors coming in a V, but they'll have still the tendency to launch the ball. But I feel like it'll lift the ball though. I don't know. I feel like it will lift it simply because it's not oriented like through like horizontally. Like, here, maybe if I draw it out, I'll be able to like see it better. So like if we had the ping pong ball, like this, right? And then we had something like so. Oops, nope, don't need that. So something like that. We have the ping pong ball, and then what we can do is, orient the motors or the wheels to be like this, so that we could actually. Okay. So we put them at an angle, and then we could probably create something that could work with this. So we could have. But like what I'm thinking is that it's gonna push the ball upward, which is what I don't want. Unless we had 4 of them. We had 4 motors, alright? I mean, we are getting like 6 of them, so we can potentially use more motors. But it might be overkill. Maybe we could do... But that doesn't solve any problem, does it? I don't know if it solves a problem or not, because we still need to like figure out how to mount these things. But maybe orientation doesn't matter. At least in the case that we could make the what do you call it? The wheels touch the ping pong ball. I think that's like the only criteria we really need. We would want it symmetric, but yeah, if it's symmetric, then we're fine. I think we're fine. But if it's asymmetric on either plane, then I believe we'll have like a net force causing the ball to move in a certain direction that we don't want it to. How do like Hot Wheels do it? You know what I mean? Like they have those racing tracks. Hot Wheel. Speed up something. forgot how they do it. I think they have very like spongy material so it grips onto the ball. Or not ball, but the car. Oh no, I don't want videos, images. So something like, how do they do this? Is this even like, I don't think that's what I'm looking for. Does this have it? I can't tell. I really can't tell. I don't know. But I think Hot Wheels has it. I remember having like a toy when I was a kid that would launch the car, and it basically used like some sort of wheel to do it. But I don't know what that wheel is or how they did it. Here we go. Something like this. Can we open image a new tab? So they just had they just had it like that basically. I don't know. This is like what I want ideally, but like, how do I do it? I mean, another way to do it is just have more pieces or more parts, so we just screw things together, but like, I don't know if I want to do that. I'm really stuck. It's probably another 30 minutes of me just thinking of like 20 different ways of how to do this. What can we do? What can we do? I really don't know what to do. Maybe, just maybe, we could, I'm really stuck, to be honest. I really don't know what to do. Does it have to be circular? Like, can we put it in a square tube? It should be fine, right? Does that solve my problem, though? Yeah, because it gets rid of the irregular shape. Not irregular, but it gets rid of the cylinder. And I feel like the cylinder is causing a lot of issues. I'm really stuck, to be honest. I don't know what to do. Okay. Maybe we'll just, I don't know, just draw some stuff until we get something. But now I'm looking at the spring-loaded shooter. I'm already changing the design. I'm looking at that. Like, how can we do that? Like, how would you reload it? That's the problem. I shouldn't waste time on. It's so bad. Because, like, now I'm wasting time. I don't know what I should be doing. If you guys have any input, let me know. Because, like, I am completely lost. We were doing well in the beginning. But once we hit the design part, I just hit a wall because of 3D printing. What else can we do? I can't like. Now, if we could mount the motors in an opposite direction, we could use some sort of like gear transmission so that we could orient the motor horizontally or along the axis of the pipe, and then have the wheel perpendicular to it, so we'll be able to mount the motor vertically or horizontally depending on how you orient the tube. Oh hey Sigma Pi, so the problem what I'm having, so essentially I started designing the tube for the ping pong ball so it gets launched out of, which is fine. But like I got to the point where I had issues with, if I were gonna 3D print this, I don't want to use a lot of support material to print something unnecessary. Um, so for example, what I had before was essentially something like this, maybe not really, but imagine this being shorter and basically hollow, so I could put the motor inside and then mount the motor to the tube. Um, the fact that it was hollow inside means that we have to print it with a lot of support material, and I don't want to waste all that support material. So now I'm trying to come up with like a 3D printed design, or a design that's 3D printer friendly, if that makes sense, or something. Like, I mean, I can print it with all that support material, but like, I just don't want to waste that much. Maybe it's not even a lot, because this does look like big on screen, but it's not necessarily big. I mean, the ping pong ball is like what, that big, so it's maybe as big as my hand. I don't know, but right now I'm just trying to think of like different ways. Like if I were to hide this, um, I'm trying to think of different ways to mount a motor to this. Basically, I want to put the motor somewhere here so that they make contact with the ball. I started thinking out loud, and essentially, I was like, maybe we could orient the motor in different directions. Like we're not forced to put it, horizontally or vertically. Um, but I think the location of the motors have to be at least symmetric, so we don't have like a net force of pushing the ball up or down. Um, that's what I'm thinking. I'm not sure if that's necessarily true, but I feel like that would be an issue. But yeah, I'm just trying to figure out another way to mount the motor to a tube with the constraint of 3D printing. Um, and then it also got me thinking like, oh, maybe we should look at a different design, because it's such a problem. I don't know what to do. The thing about this one, I like about this one, it's like it's a lot of store bought parts or off the shelf parts, and then like small 3D printed things. That's why I do like this design, but I can't think of like a reloading mechanism for it. I don't know. Okay. But yeah, I'm trying to think of a different design that is 3D printer friendly. If you don't know what support material is, we had that question before. Let me just show you, just in case. So support material for a 3D printer looks something like this. Something like, so if you look at this, it looks like a Pokemon, or this is probably better. This is like a manifold, or some sort of turbine for a car, or usually a car. But if you look at this, the actual part is in blue, which is pretty obvious. But since the part is hollow, or there's some components of the part that is basically suspended in air, the 3D printer can't print just in air. It needs some sort of support underneath it to print on. So they basically use this other material called support material to put there temporarily for the print. And then once you're done with the print, you could take this away, and then you could just like break it off basically. Sometimes it's really clean, sometimes it's like a hassle, but I'm just trying to avoid this completely, because I don't want to waste all this support material. Like, look how much is wasted for this. Like, it's insane. Um, I mean, depending how big this thing is, obviously we have no sense of scale. But yeah, that's the issue that I'm having immediately. So I've been just like trying to talk out loud for like the past hour and a half. Um, so yeah. Um, how else to mount a motor? Like I don't know, cause originally I wanted a wall. I wanted a wall with a slot so I could guide the motor and like vary the position of the motor so that I could place it where I ideally want it, because I don't want to define a specific position for the motor just in case it might be too close to the ball or too far away from the ball. I want to have a range, and then I'll just tighten down with a screw and a nut to lock its position. And then over time, if it does get loose, I could retighten it and so forth. But it just gives me the ability to vary the position of the motor. That's what originally I wanted. And then I ran into the whole, oh wait, I can't 3D print this without using a crap load of support. So, uh, and I feel like part of it's because it's just like a tube. But now I'm thinking like let's just make it two pieces. Like I just like the more pieces, the more problems we could potentially have. But it solves the 3D printing problem, I think. Yeah. So like maybe just cut this whole thing in half. That's what I'm thinking now. Will that solve the issue though? I don't. It's hard to tell. I really don't know. Hmm. Cause like now I'm thinking something like this. Let me draw it out so you could see. Um, so we have basically two pieces. Uh, we have two pieces. So maybe something. Oh, that's too much. Something like this, maybe. And then this would go out. Something like that. And then that wouldn't work actually. That would go something like that. Oh no, I realized there wouldn't be that in my idea. So what I'm thinking is cut this in half. So we'll just draw this like basically a straight line here. And then make this a half circle. That doesn't look good at all. Oops. Yeah, desktop is not on. Okay, so something. Let me fix that. So something like this. Maybe like that. I don't know. But essentially we'll have a circle here. So that's basically the top piece, and then we replicate this on the bottom. So it'll be something like this. No, this will be straight, and then this will be down. You solved harder problems before. I'm sure you could solve this one as well. Yeah, I guess I have solved harder problems. There's actually a really tough problem at work we have. It's such a headache, and it's almost as difficult as this. Well, maybe not. Maybe it's not as difficult, but um, at work, what we're dealing with, we have this box basically, uh, a box that vibrates. It has this thing called a transducer. Let me show you. because like I need to take a break from this and let my mind wander before but like let me show you this. So this is a problem I'm having at work, and me and another engineer is trying to figure out like how to do this. But transducer vibration, I don't know. These things usually go under like oh well, they don't have it, huh? I don't want to give out the specific brand or anything, because just in case it's proprietary. But it looks something like this. This is a transducer. So essentially, what it does, it vibrates. This is like magnetic coil or something inside that basically oscillates at some sort of frequency. But it vibrates. These are more commonly used in like gaming chairs. So like if you're sitting on a gaming chair and you hook up your gaming chair to your PC or your console, it'll vibrate or give you that bass when you play like video games or anything through your console or PC. So it gives you like some, I guess, it's not really haptic feedback, but some sort of like vibration to signify like bass or something. But we're using this for a completely different application. But a problem we're having is that we got this. We basically have a box with two of these in there, and a problem that we're having is to cool the transducers. Um, there's so many things wrong with this project. I mean, me and my coworker got into the project way later, like way later in the project. So we're like towards the end of it now. We're just like tweaking a few things. So I don't know. Previously, they got the whole design, their box tested, ETL tested. ETL testing is basically a certified testing that the device won't burn someone or electrically catch on fire or something like that. So we got ETL tested like a while ago, and the testing has shown that the box was capable of being cooled at its specified temperature, which is what we're seeing now. So it's technically within the range of the testing that we did earlier. But the problem is that this transducer has an operating range of like, I don't know, like negative 20 degrees C to like 100 or 60 degrees C, which is roughly in Fahrenheit. If that's like I don't know, negative 20 degrees C, whatever that is in Fahrenheit, all the way up to like 148 Fahrenheit or 100 or maybe a little bit more. But the transducer has that operating range. The problem is that the transducer is operating at a very high limit or a high hot or a high temperature, and we don't want that because we want this to have a pretty good life cycle. So basically at work we're just trying to figure out how to fix the thing, like how to make it cooler, and it's such a pain because we can't really change the design, we can't do anything with it because it's already been tested. So we just could add or tweak just small things and hope for the better. Um, Today, I mean, it has three fans in there. There's an intake, an exhaust, and then one fan in the middle. I think we don't need the fan in the middle because I think what the problem is that the air is leaving, or coming in the intake cold, right, or room temp, and then it's leaving relatively warmer, not too much warmer. I believe it's 10 degrees difference in Fahrenheit scale. Um, uh, which is, I mean, it's doing its thing. It's pushing the heat away from the box, which is what we want. We want one side cold, one side hot, but we want it to be more hot on the other side because that means we're getting rid of the heat. So what I'm thinking is that since we have three fans, there's too much airflow going through. This is not very scientific at all. It's just like what I've researched at work, but I think there's too much airflow causing it the airflow the airflow is going too fast around the transducers, meaning um, um, the air doesn't have time to heat up or collect the heat from the transducers to take it away. Um, so what I'm thinking is we just remove that middle fan or that third fan and just have the intake and outtake fans, and I believe it should maybe do a little bit better. Because what I'm hoping is that the air will come in and then it'll circulate in the box for a bit, heat up the transducers will heat up the air, and then the air will just on its own within time just leave the box. That's what I'm thinking. I don't know if it's gonna work. We have to go test it. My friend or my coworker was testing it today. I was like, maybe try this because I really don't know. Like we're been testing this thing for like a week and a half, 2 weeks already, and it's just like I don't know what to do. I can't figure this one out. And then you have like the CEO saying like, oh, we should probably just keep the design, just release it because we've been spending way too much time on this. I'm like, yes, I know, but it's you don't want it to fail though. It's just like I don't know. Yeah. Yeah, it seems to make sense. I don't know. I really don't know. There's so many things that small things that change. Like another problem we get is like when we test the probes, like sometimes the temperatures flip, if that makes sense. Like we'll put the probes in, we'll test it, and this transducer will be hotter than this transducer, but then we'll test it again and then it will flip. The temperatures will flip. Like this will be cooler, or this one will be cooler and this one will be hotter. Like I don't know. There's no there's no rhyme or reason to it. All right, Dane, I'll see you later. Hopefully you can wake up your dog. Yeah, so that's been on my mind. I mean, it's technically not my project per se. I'm just helping my coworker because all I do is like some paperwork. I just chill, mess around on the computer all day. But I usually just come to my coworker's desk and just like, oh, what are you working on? Oh, okay, we'll solve this problem or try to solve this problem. Um, yeah. All right, man. I'll see you on Monday. Yeah, the next stream will be on Monday at 6:30. So, yeah. Um, so yeah. So there's that problem as well. I don't know. But like that's what I'm here to do, trying to solve problems. But sometimes it's just like too difficult. Well, not too difficult. I just need more time to think. I also have like the perspective or outlook of um, sometimes I think it's just like I realize my light is not on. I mean, I guess it's a little late now, but sometimes I have like the idea like if I'm stuck on something, I always think like, oh well, in a few hours I'll probably figure it out. Maybe I'm a little too hopeful, but I usually think that way. Like I remember back in college, I would think like, oh, I can't solve this problem or I can't figure it out. But then since I have like a deadline, and I'll be like, oh, well, I'll have it done by the deadline. You know what I mean? Like I don't know. Um, I mean, it seemed to work out most of the time, that mentality, but it might be a dangerous mentality to have. Um, being too hopeful. But yeah, I mean, problems upon problems. Um, so yeah, I don't know. I'm stuck. Unless you guys have any ideas, I'm really stuck on this. I'm gonna. I think I'm gonna probably end the stream here since I'm really not going anywhere. I'm just kind of rambling and just talking out loud. But I'll try over the weekend to think of some different ways of doing this. Like I just can't think of a way right now because it's mostly the cylinder that's messing with me. And how to mount a motor to that cylinder. That also fits in the realms of a 3D printer. I might just say screw it and just use, or maybe I'll just buy my own 3D printer. Maybe that'll be a better, but like that's hella expensive. Well, I can get one, but it's just like I don't know if I should, and then I gotta pay for the filament. Cause I think I want to get like this 3D printer. I don't know. I've been eyeballing this for like a while now. I want this 3D printer. It's called the CR10. It's this one basically. I want this one, but in black. I want this one. It's kind of overkill for what I need, but I do want a 3D printer. It's 364, which is not bad for a 3D printer. That's pretty decent, and like it's pretty good quality. And it has is it a glass base? I believe it's glass, which is really nice. So yeah, I really like that one. There's also smaller ones, but I kind of want this one. So I don't know. Maybe I'll just get my own 3D printer and I'll figure it out. But then I have to do all the settings and set it up and all that tweaking just to get it working. But at work, I could just use their filament. But like, I don't want to waste all that filament. No, the supported material doesn't cause more printing errors. It actually helps with the print. The only issue that I'm having with the support material is that I just don't want to waste it. Because like it's not my 3D printer. I'm just gonna use the one at work, ideally. So I just don't want to waste it. And then like have like someone say, "Oh, where's all the filament? Who used it all?" And I'm like, me." I just don't want to waste it all. That's really the big issue. But I might just say screw it and just use it. Like, I don't know. Maybe I could just get like a smaller 3D printer and then I could upgrade later. I don't know. Reality. Yeah, so I think I'm just gonna leave it at that. I don't want to bore you guys too long. Like, this one might be good. This is 189. It's 200 though. Might as well just like pay the extra 100. How big is it? 51. What's that in? 51 cm, 2 inches. How big is that? Well, that's pretty big. 20 inches? Oh, is that the whole package though? That's not like that's not the bed size or the volume it can print in, huh? Yeah, I think that's the whole package. Yeah, I don't know. So, yeah, there's that. Used it to make a ping pong ball launcher. Yeah, I just wasted all the filament just to use a ping pong ball launcher. But I did use that 3D printer. I don't know if you've seen the video, but here, hold on. Let me get it. Here it is. I did use the 3D printer to make this thing. This is for like the COVID-19, the whole wrist alarm watch. It's pretty decent print. I mean, it's actually pretty bad to be honest, but on the sides it worked pretty well. Like, that's a pretty clean print. Yeah. It's just like the top layer was pretty bad. Even the bottom layer was kind of iffy. Like, that was pretty bad. But yeah, I mean, this is not much to be honest. This is a very small amount of material. See, this is what I was thinking, like make it into 2 pieces so that we can have a hollow piece or the thing hollow, and then we just mount it with some screws. So, does this thing still work? It still works. Yeah. Oh, yeah. So, I don't know. Okay. Well, I think we're gonna leave it there. For tonight, for the stream. It's already 8:30, so I'm gonna wrap it up. The reason why I'm not gonna stream 5 days a week is simply because I don't want to. I mean, it's not that I don't want to. It's more just so I can have time to make YouTube content, because I do enjoy making YouTube content regularly. I do have a pretty fun idea. I think you guys will like it. It'll be more of a series. than anything. I think it'll just be fun. It'll be way more entertaining, I think. It'll be more on the entertaining side than the technical side of things. Um, so hopefully you guys will like that. Hopefully it does really well, but no promises. You'll probably be seeing that video sometime this month, hopefully. Like I'm trying to storyboard it a little bit, so that might be done sometime this weekend. And if I could finish that this weekend, then I could start recording next Thursday and Friday or Saturday. And then the following week could be nothing but editing. So hopefully by like the 30th, by the end of the month, we should have that video out. Because it takes some time, and plus I have work, so there's a whole lot of stuff. But hopefully you guys will like that. I don't want to spoil too much of it. I kind of spoiled it on the stream with what I showed, but it probably still doesn't make sense even if you saw it. But yeah. Anyway, if you want to catch the stream or the archives of these streams, we're on part 8 now. No, not part 8, part 6. Part 6. So we already put 12 hours into this project, and we ran into our first wall. How we're going to solve it, I don't know. But we'll probably figure it out. See, it's my mentality again. We'll probably figure it out. I don't know what we're going to figure out, but we're going to figure out something. But, yeah, I'll think about it over the weekend. So hopefully by Monday we'll have a fresh start on this 3D modeling design. And we'll solve all our problems. But, yeah. So there's that. So yeah, you can find all the archive streams on my channel. They're under the live section in my channel. And that's pretty much it. I stream Monday, Tuesday, Wednesday, 6:30 to 8:30 p.m. And yeah. So I want to say, I don't say this on the stream, and I should. Thank you guys for watching the stream. It does mean a lot. I'm surprised that anyone does watch this, because it can be pretty boring. But if you're more into the technical side of things, or even if you have questions about engineering in general, feel free to let me know. Or if you have design suggestions, let me know. Like, I'm not the expert here. I mean, I guess you can consider me an expert, but like, I'm still willing to learn from you guys as well. Yeah. So I'll catch you guys Monday on the stream, and hopefully with some new YouTube content by the end of the month. So yeah. All right. Yeah. Thank you, Sip and Pie. Thank you very